Hello everyone. We may use many software applications every day. When we wake up, we check up WhatsApp. When we watch YouTube, we use Google Maps. At work, we may use Microsoft Teams, Gmail, or other applications. But have you ever thought about one question? Are all these applications built in the same way? The answer is no. WhatsApp, YouTube, Google Chrome, and Microsoft Teams are software applications, but they run on different platforms and are built using different technologies. In this video, let us systematically understand major types of software applications. Okay, so first understand the big picture. Okay, so before talking about Angular, React, Java, or Flutter, we need to understand one important thing. There are multiple ways to classify software applications. So I will use three simple questions. So question number one, where does the application runs? For example, YouTube can run in a browser while the YouTube mobile app runs on the phone. Question number two, how is the application built? For example, a mobile application can be native, cross platform, or hybrid. Question number three, which technology is used? For example, Angular, React, Flutter, and Spring Boot. Okay, so there are main types. So, where does the application runs? See, the first and easiest way to classify application is based on where they run. Okay, for example, web applications. So YouTube in Google Chrome is an example. And if you see the mobile applications, WhatsApp installed on the Android or iPhone is an example. And for the desktop applications, for example, you use Microsoft Word or the IntelliJ IDEA installed on your desktop is an example. For the backend applications, when you open Amazon or a Flipkart, a backend application processes your order behind the scenes that you cannot see it, but it is behind the scene. The next is embedded applications. The software inside a washing machine or a car is an example. And there are many cloud platforms. So I mean the cloud or distributed applications. The applications such as Netflix operate using large distributed systems running in cloud infrastructure. In short, I can say, see, when you open a browser, it is called web applications. Something is running inside the browser, right? That is web applications. When you open a phone, you see many applications. That is called, they are called mobile applications. If you open a laptop and see any native applications, that is called desktop applications. And there are server that you cannot see it physically, but you cannot see even visually, but that is running behind the scenes. So that acts the major part. That is called backend applications. And there are device specific applications called embedded applications, generally washing machine, refrigerator, TV, or many applications, for example Alexa. So they are all programmed embedded mobile applications. Okay, now let's discuss about web applications quite elaborately. A web application is an applications we primarily access using a web browser. For example, when you open Gmail in Chrome, when you use YouTube from your browser, or when you access your company's employee portal, you are using the web application. Okay, you, the user, interact with the browser. The browser loads the front end. The front end communicates with the back end, and the back end reads and saves the information in the database. So this is actually flow. Okay, so I can give some examples: Gmail, YouTube, Google Docs, Amazon, LinkedIn. So if your browser is your main entry point, it is primarily a web application. Okay. Uh, Now I tell you some types of web applications. Say now we now the web applications themselves can be further classified. Okay, so think about a simple company information website or portfolio website. The same information is generally shown to everyone. For example, there can be portfolio website, uh, company profile website, documentation website. Okay, my own portfolio website is an example of a website where visitors mainly consume informations. Okay, now think these are called static website. Then now let's move to the dynamic website. Okay, now think about Gmail. My inbox and your inbox are different. The content changes based on the logged in users. It can be Gmail, Facebook, Amazon, and online banking. Okay. Now, what is SPA? I mean the single page applications. Okay. Think about modern applications where navigations feel smooth and it gives experience like applications like. So instead of loading the entire page every time, the application dynamically updates parts of the screen. So many Angular applications, many React applications, Next.js applications. So they are the examples. Now let's move to what is multi-page applications, MPA, multi-page applications. Okay. So traditional websites may load different pages from the server when users navigate. So news websites, traditional server rendered websites. Okay. And what is PWA, progressive web applications? A PWA is still a web applications, but it can provide more application like capabilities. So sometimes it will request you to install as an app. Okay. So that is called an installable web app, PWA. So this kind of applications that can work even within limited connectivity. There can be network problem, but still it can work. Okay. So now let's understand the difference between the single page applications and multi-page applications. Okay. Suppose you are using a modern dashboard applications built with Angular or React. You click dashboard or users and reports. The screen changes dynamically, but the application behaves like one continuous experience. And what is multi-page applications? So now imagine a traditional news website, Wikipedia like. So when you open another article or section, the browser may request and load another page from the server. The important classification is the single page application does not mean only one screen. It means the application typically manages navigation and updates within the single page shell. Okay. So now let's understand about the mobile applications. So we use most frequently that is called mobile applications. What are the examples? WhatsApp, Instagram, Google Maps, PhonePay, Swiggy. hmm? But here is an interesting part. All these applications may look similar to users, but developers can build mobile applications using different approaches. So there are four types. Okay, for example, native apps, cross-platform apps, hybrid apps, progressive web apps. Okay, and so what is native mobile applications? We see something in detail. Okay. A native application is built specifically for a particular operating system. For the Android, popular technologies including Kotlin and Java. For iOS, I mean the iPhone, the primary language is Swift. Okay. So when company wants the deepest possible integration with Android or iPhone features, it may build platform specific applications. So many major applications, including apps from companies such as Google and Apple, contain significant native platform specific development. Okay. Now let's understand about cross platform and hybrid apps. Suppose I want to build an application for both Android and iPhone. I can write completely separate applications, or I can use a cross platform framework to share much of my code. For example, Flutter, React Native, .NET MAUI, Kotlin. These are all examples. Okay. So these are multi-platform supportive. A simple analogy I can give. Instead of writing two books from the beginning, I write one common version and adapt it for different platforms. Okay. Now let's understand about the hybrid. Okay. Say a hybrid application uses web technologies such as HTML, CSS, and JavaScript and packages them inside a mobile application container. For example, developers can use Angular with Ionic and Capacitor to build applications that can run on mobile platforms. Okay. As an Angular developer, I'm an Angular developer. This is particularly interesting because uh, Angular knowledge can also be used together with Ionic to develop mobile applications. Hmm. Now let's understand about progressive web applications. Now let us come to PWA, one of the most commonly misunderstood terms. Imagine you open an application in your browser. It is technically a web application, but it can be installed, open like an app, and depending on the browser and platform, provide features such as offline supports and notifications. Okay. So think of an online shopping or delivery service that you can open in directly from the browser and then it will request you to install, but within a minute it's installed without going to App Store or Play Store. So that install on your phone's home screen. So that is called progressive web applications. So PWA is not a replacement for every native mobile applications. It is another approach depending on the requirements. Oh, I'm sorry. Okay. Now, so a desktop application is installed and runs on your computer. For example, Microsoft Word, the Microsoft Office, okay, an IntelliJ IDEA, you download it and install it by give yes, yes, submit, save, finally, final, and Visual Studio Code and Adobe Photoshop. Okay, so these are desktop applications. So these desktop applications can also be built in different ways. There are many technologies that supports .NET, WPF, JavaFX. Okay, so the modern developers can also build desktop applications using web technologies such as Electron and Tori. So the Visual Studio Code is a good example of how modern desktop applications can use web technologies and still provide a desktop experience. Right? You can browse it. The VS Code gives agentic experience, Copilot experience. So we can browse like a browser. At the same times, helps us to have the desktop experience. Right? Okay. So let's understand about backend or server applications. So this kind of application that users often don't see directly, that is called backend applications. Suppose you open an e-commerce applications and place an order. You select a product and add it to the cart and make a payment. But where is all this business logic happening behind the scene, right? So one or more backend applications process these requests. So generally the backend responsibilities are like login, authentication, business logic, order processing, payment processing, database operations, notifications. So your mobile app or web app is the front door. The backend application is the engine room. So generally the technologies are used for this Spring Boot, Node.js, Next.js, Django, Fast API, .NET, and etc. Okay. Now please don't confuse this monolith and microservices with web applications or mobile applications. So monolith and microservices describe how a backend is organized. Imagine one large application containing login, orders, payments, and notifications. That's only one. That is called monolith applications. One application that handles login, orders, payments, and notifications. But microservices means now imagine these capabilities being separated into differently independently deployable services. Okay. Now again, I tell you, see the same capabilities being separated into different independently deployable services. For authentication, there is a dedicated authentication service. For orders, there is a dedicated order service. The server applications runs separately. And for the payment services, notification services. So different developers teams, they build it differently and deploy individually. They connect it through some REST or a Kafka gRPC systems. So I tell you one familiar example. The large global platforms such as Netflix are commonly associated with a large scale distributed and microservices based architecture. So you should understand one key point. So where users access, that is called mobile and web applications. How the backend is organized, that is called monolith and microservices. So this is a very important and most notable point. Okay. Now let's understand about embedded or cloud applications. So software does not always run on a phone, laptop or servers. Sometimes they are running in the washing machine, cars, smart TVs, ATMs, smart watches, IoT devices. IoT devices, I can give examples like smartwatch, Alexa, that's been controlled by voice, right? So they are IoT devices. An automatic phone, remote fan control. When your washing machine automatically controls the washing cycle, software is running inside that device. The common technologies used for this is C, C++, embedded C, and Rust. And on the other hand, we should understand about the cloud applications. So cloud is slightly different from web or mobile. So cloud often describes where and how an application is deployed and operated. For example, you may build a web application using Angular and Spring Boot, then deploy it on cloud infrastructure. So then where those applications are running, these applications are running on the application which is there in the cloud. For example, Docker, Kubernetes, AWS, Azure, Google Cloud. Okay. Next, we should understand about different frameworks. Okay. We can say framework map. Now we understand the application types. The next question is which technologies can we use to build them? That is there, right? For the web, we need to use Angular, React, Vue. and Next.js, and there is Svelte. One more is there. And for the mobile, we use Kotlin, Swift, Flutter, React Native, and Ionic to build mobile applications. For building desktop applications, we use .NET technologies, JavaFX, Electron, and Tori. For the backend application, we use Spring Boot, Django, Node.js, Next.js, .NET, and Fast API, and so on. For the embedded, we use C, C++, Rust. So these technologies are tools. We first understand the problem and application type, then choose the application tool. Okay. The most important distinctions we have to understand. Many beginners makes this mistake. They mix up application types, frameworks, and architecture. So here you should see Angular is not an application type. Angular is a framework. Spring Boot is not a backend application itself. It is a framework used to build backend applications. PWA is not a framework, it is a model for creating web applications with additional app like capabilities. Microservices is not a framework, it is an architectural style. Okay, so we should memorize one important thing. So the application type answers what kind of application it is. An architecture answers how it is organized. Framework answers which tool is used to build it. Okay, so I tell you one final mental model. Uh, so this should be your complete framework. Okay, so question number one, where does it run? Example, is it running in browser? If it is running in the browser, it is a web application. If it is running the phone, it is the mobile application. Is it running in the computer? It is the desktop applications. Is it running behind the scene like a server? It may be a backend application. Question number two, how is it built? Is it built natively, cross platform, or hybrid, or on the backend? Monolith or microservices? Question number three, which technology? Is it used with Angular, React, Flutter, or Spring Boot? Final formula I tell you, WHW, where, how, which. Okay, where does it run? How is it built? And which technology it has used. Okay, so how many types of software applications are there? There is no single fixed number because software can be classified in different ways. But the simplest way to understand the software world is to first ask where the application runs. Okay, web applications run primarily through browsers. Mobile applications runs on the phone, phones. Desktop applications run on computers. Backend applications run behind the scenes on servers. Embedded applications runs inside physical devices. After that, we can understand how they are built and finally which technologies are used. So I hope this video uh, gave you a clear picture understanding of the software application ecosystem. As developers, we should not simply memorize frameworks. First, we should understand the problem, the type of application, and the architecture. Then we can choose the right technology. If you found this video useful, please subscribe to Ask Nehru. In upcoming videos, we will systematically learn more software engineering fundamental. Thank you.